Good afternoon, everybody. Thank you very much for joining us today on what is probably the hottest day of the year, I think, in London, Nicholas. I know you've had a bit of a storm over the last couple of days, and I think we're hot on the heels behind you. It is so hot here. So thank you very much for joining us, everybody who's joining today. This is the second in our recordings of advice and information around open source software security as part of Open UK's Summer of Open Source Software Security. We had our first session last Wednesday with Kate Stewart from the Linux Foundation. And Kate was talking about supply chain and software bill of materials and standards. And we have a bit of a shift this week to what I suspect will be a little bit more practical in its discussion, looking at the Department of Defense. And Nicolas Chaillan, who is the former US Air Force and Space Force Chief Software Officer, c-ATO, and co-lead of the Department of Defense Enterprise DevSecOps Initiative, is joining us today to talk about how the Department of Defense moved to DevSecOps. And Nicolas has, as you'll see from his bio on our site, a very esteemed career across security, working for organizations like Thales on his way to the US public sector. And I'm hoping that this will be a really interesting session, Nicolas, seeing how someone has actually done DevSecOps in one of the most importantly secure environments in the world.
Indeed, that will be exciting. And like you said, we'll take questions at the end too. So if people have questions, feel free to put the question on the chat. I'll be taking a look throughout the discussion as well. Are we good to get started?
We're good to go. And anybody who puts questions in the chats or has any comments, if they just address those to us generally or to me through the course of the session, we'll pull those together at the end, as Nicolas says. Thank you.
All right. So like you said, I'm Nick Chaillan, the former Chief Software Officer for the Air Force and Space Force. I founded 12 companies before my time in the government. So I'm an entrepreneur, cyber software guy. I was asked to join the department to bring digital transformation and innovation with DevSecOps to the DoD, the largest behemoth that is the largest organization on the planet. We have a 60 billion budget of software, 100,000 people in software, obviously touching weapon systems, anywhere from jets to bombers to ships, satellites, and nuclear systems as well. So obviously very critical systems, but yet we were able to demonstrate that we can implement DevSecOps at scale across a very large organization that's very much siloed into tiny pieces. So we'll walk you through a little bit of the story and how we got there and kind of the key principles / technology / culture changes we've done over the last 3 years. I started in DoD about 4 years ago and left about 8 months ago. So let's take a look at the DevSecOps Initiative. That was a joint team across the department with the Air Force, Space Force, and Navy, and the Office of the Secretary of Defense. We kind of built two main teams to have enterprise capabilities for cloud and DevSecOps. With Cloud One is a cloud office completely abstracted from the cloud provider, so we have multiple options of clouds. In fact, we're the largest implementation of cloud in the world, with multiple options like Amazon, Azure, Oracle, and others. And then we, of course, have classified clouds as well. And then you have Platform One, which is the DevSecOps team that's able to bring a DevSecOps platform and pipeline, both in development and production, across all classification levels, and completely agnostic to the environment, so we can run on jets and bombers and space systems and so on. The main aspect was to bring this kind of timeliness, velocity, speed of relevance, ability to deliver multiple times a day, move away from waterfall principles to modern agile capabilities, being very modular and able to reuse components and Lego blocks across the teams, and avoid vendor lock-in, specifically by using Kubernetes and containers that we kind of think of as a Lego block, a bunch of Lego blocks that we can put together in a different way to achieve different outcomes across all the DoD services. So The main aspect was to also bring this at scale as an enterprise capability. So we created a DoD-wide DevSecOps managed service with collaboration tools and development tools and cyber tools and scanning and so on. We also created kind of an equivalent of Docker Hub for DoD, but we made it open source, and we have multiple organizations around the world using it. A lot of NATO partners and other agencies using Iron Bank, which is our centralized artifact repository of hardened containers, both commercial tools and open source tools. We have about 1,000 containers there to enable teams to have diversity of options and content. So that's very important to have hardened bits continuously updated directly with the commercial companies maintaining them, so we don't get stale and behind. You'll see that we also pushed a full zero trust implementation, so everything is driven around that kind of the zero trust mindset. We also integrated with AI machine learning and deep learning services, and also digital engineering and modeling and simulation capabilities to create digital twins of the weapons, so we can emulate and have a full emulation capability of weapons before deploying on the actual weapon itself. So we can do we can have a good understanding of how the system is going to behave on the cloud first, and then be able to deploy into a staging lab, and then into the actual weapon in production as well. We had 100,000 people to train a year, so you can imagine that's it's a lot of people. So we went with a self-learning capability, giving an hour a day for our people to learn. So essential for people first to catch up, and also not get more behind. And so that was mostly through partnerships with different training learning platforms online, with a self-learning and hands-on exercise capability, and trying not to take content that's biased to one cloud provider or one team. So it's very agnostic and flexible. Some of the key aspects as to why all this mattered for the DoD. First, of course, we had this notion of, okay, we want to be able to move at the pace of relevance and be able to compete, and also be able to react to cyber events. So cyber was very essential as well. So fail fast, learn fast, don't fail twice for the same reason. Of course, the DevSecOps implementation is the foundation of cybersecurity and velocity and cloud and AI ML adoption, and it gives you the scalability and the flexibility you need to get there. Of course, China and Russia are not waiting for us to figure it out, so I want to make sure we are not left behind. It's really the only way to build software, custom software, in modern days. If you want to be able to do small incremental delivery of value multiple times a day in the hands of your end user, that's how we do it. In 1 year, deploying DevSecOps with 27 DoD programs, which is a tiny piece of the portfolio, but big enough to make a dent, we managed to save about 100 years of time just by first moving from a accreditation standpoint to that is one time every 3 to 5 years with a very slow process, moving to a continuous authority to operate process that's continuously accrediting software multiple times a day. We ended up saving 12 to 18 months of time per program per 5-year cycle. And then we also ended up saving actually now between 8 months to 18 months of time on the continuous feedback loop with the end user warfighter being able to tell us what's working, what needs to be improved, or something that they don't need, so we don't waste time and resources building features they don't want. So we ended up, when you compound it, saving on average between 25 to 36 months of time per program per 5-year cycle. So obviously that leads to a tremendous opportunity to do more with the same amount of money and build better features and more options, right? So that's pretty cool stuff. We also save on average 12.5 million per program as well, but that doesn't even include the the time saved cost, right? So that's, if you look at F-35 being a $1 trillion project program with a T, you can imagine saving months or years of time is saving billions of taxpayer money. So some of the numbers we were able to demonstrate were, of course, the faster mission delivery, 106 times faster lead time from dev to prod, 208 more frequent code deployments, better software, 7 times less failure rate, 22% less time spent on unplanned work or rework, 50% less time spent remediating cyber issues, a mind-boggling 2,600 times faster recovery, specifically important for weapon systems, of course. And then 40% of the development costs saved on average, so you can actually do more for the same amount of money. And for retention and morale, we've seen 2.2 times employees being more likely to recommend the organization and stay with the team. So that's particularly important when we are competing against a lot of pretty innovative startups and companies out there. So a good case is comparing what we've seen back in 2019 between SpaceX and F-35. SpaceX has 9 vehicles, F-35 has 1 with several variants. SpaceX has 200 developers at the time, 4,000 for F-35, with a defect rate of 50% on F-35, meaning that after a week, 50% of the code had defects, which effectively meant that 2,000 of the developers were useless out of 4,000. So that's obviously not great. SpaceX is very much designed as Lego blocks, reusable blocks. So across the platforms, they have the ability to swap blocks to try different things. So it's very flexible and modular. 80% of the code is reused across the platform. Only 4% of the code of F-35 was reused with F-22s. So that's a big no-no in terms of lack of ability to reusing Lego blocks. SpaceX is able to do 17,000 build of software a day, 300 loop testing a day, updating software the day before the launch, now hours before the launch, thanks to the ability to test the software first on as an emulation digital twin, but then also as a hardware loop testing on the actual rocket. And that gives you a lot of flexibility to move at the pace of relevance. If you compare that, with F-35 at the time, they were not capable of doing any kind of digital twin or emulation of the entire stack multiple times a day, with a software update on average between 1 to 7 years, depending on the complexity of the change. That's a big impact on velocity and ability to deliver better capabilities to the warfighter. So in 2019, we started in 45 days. We put Kubernetes and Istio on F-16 jets, swapping the hardware. That was a pretty big achievement. Something that used to run A and C now could run, Python and Go and Java and stuff on the legacy hardware without even swapping the hardware. In 2021, because of the success of what we've seen, we ended up making Kubernetes and Istio the default for all Air Force and Space Force programs. And we took the U-2 jet, which was 60 plus years old, 70 plus years old jet, and we were able to effectively take that legacy systems and be able to deploy the Platform 1 stack on the jet in 12 days, bring the entire cyber stack on it, and create containers that can do AI/ML capabilities to manage the sensors of the plane, so the pilot can focus on something else instead of the pilot having to do it. And so we were able to deploy the AI/ML, more importantly, fly the jet and demonstrate we can receive over-the-air updates of the AI/ML capabilities with no impact to the airworthiness of the aircraft, all in 12 days. So that reusing of enterprise capabilities we built throughout the 3 years time frame really enabled us to get this stuff done very rapidly across teams. So that was a big win right there. And so the way we thought about reusing capabilities and the way we kind of cut layers, we kind of decided to split it in different ways. And as you can see here, we separate the infrastructure layer, whether it's a cloud or a weapon or edge system. And then we put Kubernetes on top. We have different distributions of Kubernetes that we use. And then we put our CI/CD pipeline using containerized tools only on top of it, on top of Kubernetes. And then the service mesh, we use Istio mostly to bring zero trust enforcement and telemetry and all the good stuff we need. So that was a big win. And effectively, application teams inherit about 85 to 90% of the NIST 853 controls. So that gives us a streamlined ability for teams to focus on their mission software. So they don't have to reinvent the wheel when it comes to all these enablement layers at the bottom here, so they can focus on building actual mission capabilities across teams. The beauty there was to effectively provide all this stack to different program offices and innovation teams. As you can see, we have a lot of them across the DoD and even other agencies and startups and other teams like that. Gives us a lot of flexibility there with the massive ecosystem touching anywhere from space to jets to nuclear systems to bombers and so on, ships. So very exciting, to be able to spread the expertise across all these teams, so they don't have to build their own platform in the vacuum and spend all this time trying to figure it out. So that was a pretty big win to provide a turnkey DevSecOps capability to all these teams that used to spend millions of taxpayer money per team to do the same thing in vacuums. So if you look at a DevSecOps pipeline, of course, that's just an example. We have 1,000+ containers, so people can pick the right tools to get the job done and use whatever they want to use. We have 16 programming languages, 23 databases, and so on. But effectively, everything is containerized, so we can easily update all these tools across all the instantiation of DevSecOps across all these program offices that often are gapped on classified systems. So by being able to use automation and containers, we can make sure we can replicate and instantiate a replica of the DevSecOps stack with a push button deployment using infrastructure as code and configuration as code. So that was a pretty big win right there. We picked Kubernetes because we wanted to be abstracted, wanted to be agnostic to the cloud provider. So by ensuring that the stack we use was CNCF compliant, gives us that abstraction. So we're not getting locked into a Kubernetes distribution. Of course, containers are immutable, so we can centrally accredit them and harden them and share it across teams, both for open source software and commercial software and government software. And then Kubernetes brings a lot of baked-in security and benefits. First with resiliency, so we have self-healing capabilities. So when container crash, they can be automatically restored. We have that baked-in security because we inject our cyber stack as a sidecar container to be able to inject zero trust and telemetry, monitoring, and logs aggregation, and all the stuff we need to know what's going on in terms of behavior using AI/ML capabilities, and all that is injected and decoupled from the mission software, so we can update all this stuff pretty rapidly. And then we have the flexibility aspect thanks to the Lego blocks and the containerization, so we can swap containers with no downtime thanks to modern routing and load balancing capabilities. We have the automation aspect where we can just push button deploy the entire stack using GitOps and infrastructure as code, configuration as code, and policy as code. So everything is code in Git. We'll talk about that in the next slides. And of course, it auto scales up and down based on demand and based on the requirement of compute or memory So that gives us the ability to also save money when it comes to performance and scalability. So we picked Istio on top of that to be able to bring a zero trust enforcement stack. And it's also decoupling a lot of the mission features in terms of service discovery, API management, authentication to the service mesh. So teams across the world can not have to coordinate releases because the service mesh is injecting a sidecar proxy using Kubernetes. So we have the ability to do dynamic routing with A/B testing and canary releases, and have the observability, chaos engineering, fault injection to see how the system behaves if something goes wrong, and maybe container crashes or something like that. It gives us kind of that flexibility of deployment and routing. Of course, it gives us a full layer 7 load balancing and zero trust enforcement for the east-west traffic and the north-south traffic with the gateway, using mutual TLS tunneling and short-lived certificate for authentication as well. So that was a very, very big benefit right there to have that zero trust stack baked in, and teams don't have to worry about it. It's already there. They don't have to reinvent the wheel. It's already built in and baked in. And Infrastructure as code is giving us that flexibility of instantiation. So we have no drift between development, staging, and testing and production environments. So no human make changes in production. In fact, we avoid having humans at all in production environment. Everything is in Git, and that's a source of truth of your desired state. It's immutable, it's replicable, it's automated. It reduces the attack surface by disabling ports like SSH and so on. And everything is code, configuration as code, and networking and tests and so on. That led us to the evolution of infrastructure as code to GitOps, with making Git the single source of truth of your desired state. So if you want to know what your system should look like, all you got to do is look at your Git repo, and you know exactly what should be running and how it should be running and how it should be configured. And there's no drift between instantiation of that stack across teams, across air-gapped or edge or classified clouds. So everything from infrastructure platform and the applications on top are all using the GitOps model. Gives you the auditability and compliance enforcement with consistent deployment and rollback if you have issues. And of course, it's great for disaster recovery because all you got to do is back up your databases, and you know, you get the beauty of a consistent back, you know, ability to recover from disasters. You have to back up your Git repo, you have to back up your databases and your data, and now you have a full backup of your entire stack. And we use GitOps for change management enforcement with multiple set of eyes on changes. So by having multiple people kind of approving a change based on the criticality of the change, it's never just one set of eyes, it's always at least two, if not more. That gives us the ability to enforce change management and understand risk better and understand what's going on in the system. And Kubernetes pulls from Git, so you know, that's the beauty there. It's not a push. So the CI/CD pipeline does not have the keys to the production environment. It's the other way around. The production and the staging environments pull from Git multiple times a day to apply the desired state in production or in staging. So there's never drifts and no human in production to deploy stuff manually. We use mostly Flux, but also Argo. We talk to CNCF projects, open source projects. Let's see. Learning is so important, right? We had 100,000 people to train, and we wanted, you know, unbiased training and content. So we created a lot of partnerships with different organizations like Pluralsight and Udemy and O'Reilly and so on, and created a lot of content, and also giving an hour a day to our people to learn, so they can keep up and make sure that they're not getting stale. we're pushing some of the right certification that are already hands-on and that you can just cheat your way in by just reading a book. It's really something you have to really understand to get those certifications with the certified QAs, application developer, the certified QAs, security specialist, and the certified QAs administrator from CNCF, and then now the T-Trait certified ISTU administrator certification as well. So that gives us an ability to really train people and make sure we have the right skills to maintain and operate all these open source foundational capabilities. We created a bunch of services, right? So as an enterprise service, I wanted to have different options, things that would be free, things that would be paid. So first we created Repo One. Repo One is the source code repo, and so we made the largest contribution to open source from the U.S. government standpoint, with the 80 million a year, engagement here, where we open source all of the DevSecOps work we've done at Platform One and all the hardening we've done of containers and things like that. So everything is on Repo One right there for everybody to see. And Iron Bank is a repository of containers hardened already and signed by DoD, where we have 1,000+ containers also open to the world. And then we created, so those were free that the government provide. And then we created Big Bang, which is the Platform One DevSecOps platforms, and that runs both in dev but also in production to be able to do all the zero trust and the continuous monitoring enforcement in runtime. So it's also part of the weapon. So it's a weapon system for us as well. And so Big Bang is fully automated push button deployment. So teams can go and get a replica of Platform One and all the work we've done and all the enforcement layers and cyber supply chain and scanning and so on capabilities are baked in there. So people can go and take Platform One, Big Bang, and deploy it on their clouds or their environments. And then we have a party bus environment that's effectively a Big Bang managed as a service by Platform One. So teams that are doing DoD work and are trying to access DevSecOps environment, they can simply pay Platform One a developer and get access to an existing environment already accredited and ready to go. So they can onboard their people and get started coding right away, streamlining the process there. So that gives obviously a lot of flexibility there. If you want to know more about some of that architecture and maybe more deep dive videos on how we implemented zero trust and all the stuff we did, we have a couple of websites on the software.dev.mil website. You're going to find under DSOP documents, you're going to find a lot of videos and training. And we kind of gave a lot of background on how we made all these decisions and how is the architecture designed for DevSecOps in DoD. A lot of great training videos on the training page. And then, of course, we have my show every Tuesday now. Actually, we moved to a weekly model at 1 p.m. Eastern. We have guests talk about culture, DevSecOps, and kind of how to get it done in a very large or smaller organization as well. And then we publish a lot of video content to kind of spread the knowledge and help organizations outside of the government, banks and telcos and retailers and so on that wanted to embrace DevSecOps. And so we really gave a lot of video content on that YouTube channel as well. So I see there are a couple of questions. That's my last slide. So Amanda, you want me to read the question or?
I was just about to ask you some questions myself. I really like the fact that you said something early on about fail often, fail fast, and don't fail for the same reason twice. Now, you're speaking to a primarily British audience today, and we're not very comfortable with the whole concept of failure, not like the Americans. How important do you think that's been in the strategy that you've adopted?
Yeah, I don't think you can innovate if you're not failing, so, and you want a control failure, right? When we say failing, we're not saying there's a plane that's going to fall off of the sky. Okay. We're just saying if you do small incremental delivery of capabilities, the failure would be small and negligible. and you will be able to recover very fast. We've seen, the 2,600 times faster recovery, right? That's a massive win. And so you can innovate. Elon Musk was always saying, if you're not failing, you're not innovating, you're not trying hard enough, right? It's not moving fast enough. It's not relevant, and so competitors are not waiting for you to wake up to do it. So we're in a universe where the timeliness and the baked-in security must be tied together, right? So by having that baked-in security concept, that really streamlines the whole process. So it's not bolted on after the fact.
And how did you go about having that conversation? Because I suspect when you're talking about failure in the Department of Defense, that's possibly something that made people very uncomfortable. So how does one have that conversation in such a secure environment?
Yeah, first you have to explain what failure really means, right? And like I said, it has to be controlled, and it has to be, a step-by-step process with small incremental delivery of value. And so you have to educate and spend a lot of time, explaining the agile methodologies. And a lot of people, unfortunately, particularly in DoD, have never had any training on agile. And so even when they try to do agile, they still do it on the waterfall way, So the first piece was really the educational piece of understanding the basics of agile.
Yeah.
And then we started showing, good case studies like SpaceX and how they do it, and that's the thing, you want to bring tangible examples. When people were mentioning, we should do like Netflix, well, the generals are like, oh, we're not doing, videos, stupid videos, we're doing weapons here, it's not the same risk, which is true, so not using Netflix as an example is probably a good idea, right? So we started instead talking about SpaceX and Tesla, right? Because that's going to relate a little bit better to the audience.
Yeah, that makes a lot of sense. I think also the managing risk understanding in whatever organization you're in, because everybody has a different risk profile, and that risk profile is going to be extremely different in something like the Department of Defense, where it's high security, I imagine extremely conservative. One of the questions that we have here is around cloud, and you mentioned that you'd created a cloud agnostic environment. And the question was about your final slides, where are the other cloud providers?
Yes, we obviously have to deal with classified clouds. Unclassified clouds. Clouds have to be FedRAMP, right, to be approved for unclassified use. So we wanted to be agnostic. So we built a layer of identity management and cyber stack that can then run on all these clouds, and you have a single identity across all clouds. So for people consuming the cloud, it's very much streamlined. And so we went with the big ones, right? The IBM, Oracle, Amazon, Microsoft. I'm not sure I'm missing them.
AWS?
Yeah, Amazon Azure, Google, and
everybody.
Oracle and IBM.
Yeah, all the big ones. So all the big ones. Yeah, it's interesting. Yeah. And I mentioned at the start that last week we had a conversation around supply chain and SBOMs, and I noticed that you picked up on supply chain as being one of the important factors that you looked at. Can you talk a bit more about that supply chain and the relationships and importance?
Yeah, so we pushed this SBOM new presidential executive order signed by the president last year, when we were already using SBOM as a foundational piece of understanding what's inside of the software, and looking at CVs and looking at dependencies and integrity and provenance of the bits, right? So that's something we already had in place before the president mandated it, and I helped do that and write the executive order to do it. So it's essential, right, to really understand what's inside of the bits you're consuming, whether it's a commercial product or open source product, doesn't really matter. So now it's a must. It's a mandated thing we have to do anyways.
It is, and I know, talking to Kate last week, I think her stat was over 70. It might be 78% if I remember it correctly. We've just shared Open UK's State of Open report, and we're looking at a percentage of organizations saying that they're utilizing SBOMs being in the 20s. I wonder how much you think that order has shifted things in the US. Obviously, for you, you were already using them and you were an influencer in that process. Do you think it requires legislation as the US has done to move the needle?
Yeah, I mean, it doesn't hurt, that's for sure. Getting the right push from the top, right? I mean, people should do it if they want to be secure, pretty common sense. But as you know, getting a big push from the policy standpoint or the law
Yeah.
will help. But you want to do it right too, right? Because sometimes it backfires, right? Because you could also end up losing companies that don't want to deal with all the headaches, and they're going to focus on other markets first. And so if it's only mandated to the government, that's probably not a good idea, because most of the commercial companies will then go and focus on telcos and healthcare and whatnot, and then the government will lose access to best of breed products. So you want to do it, if you're going to mandate it, I would mandate it for every market, and do it globally.
Mm-hmm. And that global reference is interesting. Are you starting to see a more joined up approach, do you think, to how security is being managed across not just the US Department of Defense, but globally?
Yeah, I mean, certainly, I think there's a lot of exchange, particularly between the Five Eyes nations. I think there's a lot of great discussions. A little bit harder with NATO, but the bar is pretty low, when it comes to NATO, unfortunately, because it's kind of the least advanced of all the nations in NATO, and not the goal is not the most advanced. So it's always, almost like putting people down, instead of raising everybody up, so that's
Yeah,
NATO
the
is
lowest
pretty
common
tough, right?
denominator.
But
Yeah.
yeah,
And
the
one of
lowest common
the,
denominator.
yeah, and one of the things that you mentioned as you were talking was digital twin. Again, I suspect that you've not really seen where that's going in the UK, but digital twin has been a really big focus in our public sector. And I think you mentioned that it was used a lot with emulation. Can you talk a bit more about how you find the utilization of digital twin? Is this something that you were leading on, or is it commonplace in the US already?
Yeah. So it's growing drastically, right? Because we understand that the ability to know exactly how the system is going to behave before even bending metal, and being able to completely emulate it. And that's what SpaceX does, right? 17,000 times a day first as an emulation, and 3 times a day on the actual hardware. That's due to the constraint and limitations of the hardware in terms of volume, right? Because to run all the tests, it takes a lot of time. Versus on the emulation stack on the digital twin, you could do 17,000 a day, right? So that gives you a lot of ability to innovate and see how the software is going to behave. And the more realistic your digital twin is, the more likely you can move faster with less risk. So it's directly proportional to your maturity of the digital twin itself. And it's an essential piece if you're doing anything that's hardware, software, embedded system related. You must have a digital twin in 2022. You just can't succeed if you don't.
Yeah, there's a couple more questions come in. I'm not sure, you might pick up on this one more than I have. I'm not so sure where this comes from in relation to your talk, but an open source library developed by an open source community can be accepted. I think they mean into the SBOMs and the supply chain. Do you have any examples of where that's been done?
Oh yeah, I mean, probably 70% of platform is open source. So consuming open source libraries is definitely okay. In fact, I would argue it's more secure than commercial black boxes, right? But of course, you want to do it right. You want to look at the community behind the project. You want to, maybe do proper scanning of it and stuff like that. Have eyes on the code. If it's an important thing like UAs, we have people with eyes on the code. Stuff like that.
Can you actually, I think that's a really important point, and it's one I've come across many times. You suggested it is possible that open source could be more secure than this black box proprietary environment, and you're talking about eyes on the code. Now, we've seen various examples in the last 12 months of incidents where that's actually worked, but can you talk a bit more about what that means, the eyes on the code, and the whole good hygiene and good housekeeping of open source that you're referring to there?
Yeah, no doubt. I mean, that's the only way to consume open source safely. You can't just pick random projects and hope for the best. You want to have a good understanding of who is contributing to the project. Are you dependent on one person in his basement? We've seen, single contributors sometimes deface their own projects to make some political statement or whatever. That's just not good, right? You can't do that. It's killing the open source community, So,
but it goes against everything that open source is about, where it's for everybody, right? It goes against the open source definition. Yeah. It's incredibly problematic.
And it seems people still struggle, right, with the open source aspect of it. They fail to realize they're giving away their rights. They, for some reason, still believe they own the IP of the source code, and so they think they can just do whatever they want, and potentially tamper with the code and create significant problems. So that's the non-starter. So that's why paying attention to the community and who is behind it is very important. And then of course proper scanning and due diligence on the security side. And but you're gonna miss malicious code. Malicious code in nature, designed to be malicious, could be very good code quality, but it's malicious in nature, and there's a chance you're not going to see that, and that's why the runtime continuous monitoring we have is essential for preventing the SolarWinds type of events.
And that's the downside, right? Everything we're looking at software, so we're looking at it being a security being a software issue, not an open source issue. Each are proprietary, and open source have different issues, and that is the downside in the open space, that these things might happen because of the transparency, but then there's the upside that you're already discussing there. When we talked before about SBOMs, I didn't ask you whether or not the format you were using was an open standard. And I think you were doing this early stage, so I don't know if these would even have been released at that stage, but did you do a native SBOM format, or did you do something that was already out there in the sector?
Yeah, at first we started with our own stuff, but then we moved to SPDX, the Linux Foundation standard. So always trying to go open source. But when we started 3 years ago, I guess we just created our own formatting, but it was pretty easy to turn into SPDX instead. So,
and for anybody listening to this who is joining us at this stage in the Summer of Open Source Software Security, or watching the video, you'll see that the prior episode of first of our series actually is Kate Stewart from SPDX, who covers that standard and supply chain and SBOMs as part of her talk. I was interested to hear when you said that you had made the largest contribution from the US government to open source software. Can you talk a bit more about what that was, what drove it, what form that took? I mean, is this the collective of everything that you've done?
So we want to. Yeah, it's effectively 80 million a year of taxpayer funding. So it's ongoing. It's never ending, I guess. So that's good. It's gonna keep improving and growing. But the key for us was to be able to get adoption of the platform and stack across industry, because if we were to make it close hold, and none of the big DoD contractors, the Lockheed of the world and Northrop and so on, would be using it, and so then they would try to create their own secret sauce DevSecOps thing, and we started to see that. And then when we open sourced ours, everybody moved to it. So like Lockheed, announced they would be using Platform One for all of Lockheed's work, even non-DoD work, because they wanted the same stack across all their teams. That's a good example of making it widely open. Of course, you also now give a lot of insight to China and Russia. They're going to be able to see that, obviously, but we felt it was more important to also get the commercial sector engaged and contributing and have a two-way street there than the downside of also sharing the stuff with China and Russia. So.
And that commercial sector engagement, do you have any advice on how to get both the public and commercial sector working together on that?
Yeah, I guess being open and bringing tangible value and engaging with the community was always pretty simple for me, and so we right away, joined the CNCF and Linux Foundation, and started interacting a lot and giving presentations to companies. And then we got financial industry and healthcare and whatnot also start contributing, and NATO nations and Five Eyes nations. It's just everybody started to start engaging, and most people will consume more than contribute back, but that's okay. And then when they get better and get more maturity, then they start also sharing back. And so the government at first struggled with that because they felt we're working for them. But I knew that once they get mature enough, then they will also give back. I know we have free labor, right? So it requires a little bit of an initial investment, but that's okay because it pays off tenfold down the road, so.
It's that journey, right, where you start in the consumption space, and then you become a contributor and eventually a distributor as time goes by, and you get more engaged, right, and you understand the environment better. We've got a question here about the levels of protection and security, and whether space software technology has the same strategy and level of protection as the defense sector as a whole, or are you differentiating between different parts of the DoD?
No, it's the same. Of course, the difference, just like a jet or other systems, it's often not running on x86 CPUs, so it's often embedded systems CPU. So we have to adjust to some of the constraint of real-time OS and stuff like that. Also, of course, you often disconnected, so it has to be able to work completely disconnected and then connect back and synchronize and share data or consume data or publish data back to the ground stations. So it's the same concept. You would have jet anyways, but it doesn't come back down, so you can mess up. Jet, you can bring it back and update the software by hand if you have to, but a satellite, you can't do that. So
no,
that's
that would be a bit difficult.
Complex, but
yeah,
it's the same software.
And the thing that really struck me when we were talking before and today is the way that you managed education. And obviously that skills development through collaboration is a big piece, but you were talking about a whole hour every day. Now that must have taken some persuasion to be able to achieve that. Can you talk more to the importance of that and how you did it?
Yeah, it's always interesting to me that people are, paying quite a bit of money to bring contractor in the government, and they expect the company to just fund their learning, which is fine, but they don't want to give them any time to do it, and then they wonder why the people end up either leaving or getting frustrated or getting stale. And so you're just hurting your own programs if you don't invest in your people, regardless if you're using military or civilians or contractors, right? So for us, I always felt like enabling people to learn regardless of the status of the people is so essential. Now, not everybody's going to give an hour. Maybe you give 30 minutes and the person also takes 30 minutes of their own time. That's why I tell people, invest in yourself. Don't wait for the company to do it for you. That's not an excuse. Just do it. Just do it yourself. You don't need to wait for someone to wake up to do what's common sense and the right thing to do for you. Now, of course, if you're lucky and your company is giving you some of the tools and maybe they pay for some getting certifications and getting access to a learning hub. And that's why, I couldn't find the right content. It's funny. You have so many learning platforms out there, right? Often the content is biased, right? Because it's paid or designed by a Microsoft or Google or whatever, right? And so you're going to learn it the Microsoft way, and you're going to completely get locked in to the cloud provider, right? So for me, it was non-starter. So we managed to create some content that was a little bit more abstracted and less pushing for a cloud provider secret sauce, right? But then I also couldn't find any kind of training when it comes to managers, sales, marketing, or maybe tech guys that are just a little bit behind. They got behind. They want to catch up. They don't know what Kubernetes is, container service mesh. They don't know any of that. So I had to create my own. I'm going to launch it in August. But I had universities come to me and say, hey, you know, we want to use your stuff and want to create a curriculum, you know, and of course they charge a fortune, you know, but they were like, well, we want to do this, but we don't want to update it more than every 5 years. I'm like, that's not an option. You can't do that. Right. So I have no problem taking your money, but they don't want to spend any money on updating the content, you know. I said, you know, if you don't do at least 3 years, I'm not doing it, you know. So none of the, and I'm talking big universities that everybody knows, and none wanted to do it, right? So I had no choice but to create my own learning platform. It's going to be launched in a month, because I have all these CIOs and CTOs and their teams and all these people asking the same question and kind of struggling with going past the buzzword, right? Because that's what people do now. They just, you know, oh, it's containers, you know, they have no clue what it is, but they use the term, you know. But I think it's important to understand why it matters, what's behind it in a non-biased way, you know. I have no affiliation with cloud provider or whatever to be biased, you know. So we're releasing that, and we committed to updating it every 6 months to a year, and you know, publish new segment of videos, and we're gonna have a Q&A group, right? So people can go live and ask questions, and then we're gonna have, you know, events and stuff like that, right? But it's because we just couldn't find, you know, something that's not either a sales pitch or biased, you know. So it's just frustrating, you know.
Yeah. And you've given us a bunch of links in this final slide. Is one of those going to direct people to that training content, Nick?
Yeah, so if they go on In a Nick of Time and they subscribe to, we have a mailing list there. We don't spam people. Okay, we do one event a week, so we send an email a week to say who's the guest is going to be and stuff like that. But they're going to get a notification for the learning platform, and you know, we're also creating certificates, you know, with the Linux Foundation to be able to for people to get a fancy piece of paper at the end of it. But it's never ending, right? That's the thing, right? It's continuous self-learning. That's why I keep saying invest in yourself, because it's just, people have no problem spending a bunch of time on stupid, you know, videos on TikTok, right? But they don't have the time to take 30 minutes for their careers, you know. So I want to end the frustration, you know, when I talk to people, is they don't know where to go. There's so much content on YouTube and stuff. How do you know you're learning the right stuff? How do you know, you know, you're not getting brainwashed, you know, to bleed the color of a cloud provider, you know? So, you know, getting something that's created and trusted and, you know, and continuously challenged in terms of, you know, velocity of time, and is it still relevant? Is it still something that still works today? You know, that's what we're doing, and you know, we want to make it easy for people, you know, to learn.
I think that sounds great, and I'm just going to take advantage of the last moments that we've got with you today to ask you about a word you've used multiple times, lock-in. And it's something in the public sector that I think is really problematic, because some of the ways I see us shifting to our use of open source in the public sector actually doesn't really escape that lock-in problem. And it seems to come from a lack of understanding of what open source really means. So as we wrap up, I wonder if you just give us some thoughts on that, avoiding lock-in and moving away from it using open source.
Yeah, I think it's important for everybody. It's, you know, whether you're public or not, but public, of course, now you're spending taxpayer money, so you need to do better than this, right? And I've seen us getting locked in with a company and paying extended support for years. You know, we still pay extended support for XP and Windows 7 and cost billions. You know, Microsoft is pretty happy about it, I'm sure, but I'm not sure the taxpayer should be happy about it. And it's just you know, particularly with cloud provider, I think, you know, you don't know who is going to be innovating down the road and creating a new feature or creating something. For us, on top of it, you know, we're going to run the software on jets and bombers. It's not going to be Amazon on the jet, right? So you need to be decoupled, and you need to be able to run anywhere, and you need to be able to do edge and air gapped and disconnected, and right. So based on the mission, like, you know, if you talk to telcos and you talk to banks, they already do that because they have to, right? They work air gapped, and they have on-premise stuff, they have cloud stuff, they have hybrid, right? Some other companies may say, well, you know, it's not too important for me, I'm a SaaS, but that's true. But now you see also a shift. You know, many companies are demanding that SaaS solutions now run on their Kubernetes cluster, on their cloud, because of breaches like Okta, you know, with 2.5% of the customer are getting breached, and they had to wait 4 months to be notified. And the issue with SaaS is you have no visibility. If they don't tell you, we never know. That's just not good, particularly when you're talking about identity management, which is, probably the most important cyber capability you need to trust or not trust users using zero trust. So delegating that to a third party where you have no visibility of risk and no visibility of runtime and what's going on the cyber side is pretty foolish, I would argue, borderline criminal, right? So like you said, it's always back to what people know and understand. That's why the train is always back to the training. Every time I go back to the training, because it's like architects, right? We're not missing developers in DoD. We're missing cloud native architects that know how to architect software to be agnostic to the environment, right? There's ways to do it. People argue it's cheaper not to do it, and you're going to save time. I can tell you, being cloud agnostic nowadays is maybe a 10%, time tax, and the benefit vastly outweigh the 10% slower pace. So, and not to mention like the cost on the road. But what if the cloud provider decides to triple the cost of a service one day? You are at the mercy of, you have no option at that point but to say, yes, sir, I'll pay triple. We can't do that for the government. It's not going to work. So, yeah.
Nick, it's been a brilliant session. I've really enjoyed it. Thank you very much for joining us today. I really appreciate your time. The video from today's session will be available by early next week, and we are sharing Kate Stewart's video from last week today. We will also be welcoming Brian Bellendorf of the OpenSSF to a similar talk next week, where he'll be talking about the work that OpenSSF has been doing with the White House and beyond. Thank you very much, and I hope to see everybody again next week.
Thanks, everyone. Stay safe. Bye-bye.
Thank you.